Hi, welcome back. At the end of our last video, we left it with the filters not being explained. Hadn't explored those far enough to be comfortable walking you through some of that content in the last video. If you haven't watched the last video, I suggest you back up one and watch the PCG Biome video that precedes this one, and then come here for an explanation on the filters. So in our last video, we showed this macro view where we talked about the various elements of the PCG Biome generator. And I had made some comments that I hadn't explored the filters and how they might work. So in this video, we're going to dig into the filters a bit more, explain how they're used in the setup. As a bonus at the end, we'll also talk about the transform graph, and we'll talk about the assembly asset, just as sort of bonus, but the bulk of this will be on understanding the PCG graph filters. And there's two aspects of this. Obviously, the graph filters themselves, which are stored in the PCG core or PCG Biome core, as well as the parameters that are set in the Biome asset data assets. So let's explore those assets. You'll note that in your Biome core, there are two filter settings, one for root points and one for children points. These two filters are executed on the data sampling of the root, which is the large grid that we've been looking at with the colored points in the world. And then for each point in the world, we have the opportunity to generate children points, and then we can apply a filter to those children points. And so the two work on two different data sets. Whatever you put in the root point filter is going to automatically be run once you generate your data set of points. And so if you open that up and take a look at that, you'll find the main graph, this Biome core filters, and then it has some parameters, which is a series of subgraphs that it runs. And so it will run each of these subgraphs when you run the Biome core filter loop. So this is basically a loop, and then each iteration of that loop, it's going to apply each of these filters. The first filter here, you'll note that there is no filter graph override. So there is no override of the graph. It uses the starting graph. The filter attribute range min and range max, these are used in the graph. So all three graphs, or all three instances of the filter, expect something to be the filter attribute, something to be the min, and something to be the max. In this case, the first one is position Z. So it's looking for a height, min, and max to filter out any points below the min or above the max. Once it runs that, it will then run a second pass on density, and it will sample your density between a min and a max. And then the third filter, after those two filters have been applied, the third filter says, I want to understand the distance this point is from a water body, and then I will filter out anything too close or too far away from the water body. That's the one that I didn't quite understand until I dug into it a little bit, but we'll talk about that. So that is how the filter is set up. You have a main loop graph here, and then you have subgraphs that process the data set recursively through these sets of parameters. So here's that main loop, and you'll see here that when it comes in, it's basically storing the color attribute and then reapplying the color attribute at the end. It takes that data and then runs whatever filter is in the loop. So this is the running loop. And in that loop, you'll see that it has the opportunity to change the filter graph right here. So if you set a filter graph, it will change here. Then if you set the filter attribute, it will change here. The min and the max are here, and those are all processed through these filters. So the min, max, and target are whatever you set in the properties file. And then it's basically deleting the nodes that are not matching those criteria. So here's the filter run loop. If you look at the property values, you'll note that there is a $ on density, but not a $ on some of these other ones. So no $ on water distance, no $ on the min and max, but there is a $ on the filter attribute. That just means that filter attribute density is a property that is native to the data set and can be referenced directly with the $ indicator. The other ones, the density, min, max, water distance, are defined in the code. And specifically, if you look at the water distance filter, that one has a node right here that's going to add water distance, the specific tag water distance right here, as an attribute on its output. So anything that comes out of this is going to be tagged water distance so that we can use this filter. So the water distance filter itself has a constant water level, which you would have to set consistent with your map. This is why mine was not working. There is no input pin for the water distance, or the water level. So if your water plane is sitting at -1,000, you're going to want to go in and modify this graph so that this is -1,000. It's a constant. The same with your max distance. If you this is just sort of an arbitrary cutoff on the distance that you want to track, so that maybe you only care about 5,000 units away from water or 10,000 units away from water. You're going to stop running the calculation of how far an asset is at that max. So an asset will have a value between 0, which is if it's right at the water level, to the distance, the max distance, which again is a constant. It could be 5,000, 10,000, whatever number you want to put into it. Just know that the bigger that number is, the more attributes you're adding to your data set. And each of those attributes will be tagged with their corresponding water distance from the z-plane that is the water level. So that's how water distance becomes an attribute that can be filtered on. If you do not create a water distance attribute, when you enter this here, or if you mistype this, you'll get an error. So this has to match the output of this node here exactly, or else you won't get a match. The density comes from the properties, and these come from the array. So if you look at the output attributes, here where we had water distance, instead you see this plus sign. If you click that, you'll see all of the default properties that could have been used with a $. So you could use $density, you could use $position.z, you could do rotation, scale, transform, steepness. All of these are default ones that are there. If you're not using one of these, then you have to calculate it and output the attribute like the water distance one does. The other thing is that the structure that defines the biome asset type has these specific field names: density, min, max, height, and water distance. They are part of the struct that defines the way this data asset is. If you wanted to have more values here, you would have to modify the C++ struct so that you would get incremental. So you can't just arbitrarily add names. This is not an array. You don't arbitrarily add rows. This is part of a struct, and therefore if you wanted to extend it, you'd have to go into the C++ and extend it, and then you'd have to create your own graph similar to this one, because these names here have to match whatever is being crafted. So you could add your own maybe mountain distance filter. You would have to then determine that it is a mountain distance in this attribute set. And then you would have to go into the struct and create a min and a max so that you could do the min and the max here. So that's kind of how the filters work. We're going to go look at them in editor in a minute. The other things that we did not cover in the prior video was the transform graph. And the transform graph has a lot of uses. What it can do is take the sample point that you have and do a bunch of things to it. So the most common would be to rotate it and scale it. But you'll note here that in my transform points graph, which I created called transform, apply rotation, and z-scale, I'm rotating 0 to 180 degrees around the z-axis. I'm scaling between 0.5 and 2.0, but these are constants. And so as the way the system is currently set up, you have to recognize that the transform graphs are largely constants-based graphs as they come out of the box. Yes, you could probably expose these as properties and do different things, but the sample ones that you will see are basically sort of some hard-coded variants. You'll see in examples if you look at the things where they duplicate it, so they put two, stack one on top of the other. They do things where they raise it up off the ground. There's some interesting ones where you replace a single point, like a single mesh point, with 10 or 15 scattered points around it. Basically, they take one point and they transform it into something else, either duplicating it numerous times or just rotation and scaling. So the transform is how you apply your sort of scale and rotation. And then again, if you want different scales and rotations by different assets, you'd have to duplicate that graph and change those settings, or create a graph that would allow you to do that on the fly. The other asset that's referenced is an assembly, and there's an example in the example project. The basic workflow for this is that you create a level, not unlike a level instance, but instead of converting that level instance to a packed level actor, which again, we have a video on that if you want to explore what a level instance to a packed level actor is. But this is a very similar process in that you first create a level instance, which is this asset here. You place a variety of meshes in that level, and then you create this PCG data asset that is takes in the exporter class, which is something they provide. You give it the object path being this example map, and it will output the PCG data asset. So basically you're doing a PCG data asset that says take this level instance and treat it like any other asset. So you can now do a mesh, you can do an assembly, which is this level instance version, or you can do an actor, which is what I've been doing, which is to use an actual blueprint because I want to be able to interact with it in the world. So meshes and assemblies are good for static objects that you're not going to interact with, because a mesh becomes an instant static mesh, and assembly is obviously a collection of instant static meshes, whereas an actor will be a more overhead to manage. So hopefully that helps you understand filters, the transform graph, and the assembly object. So with that, let's jump over into the editor and we'll look at the setup a little bit more. So before we jump into the filters where we'll spend the most of the time, let's take a look at the transform graphs. So if you jump down into your PCG Biome sample content and then into Biome assets, you'll see these two filters here, child boulder to transform and child border transform. And if you open those assets up, you're going to see a PCG graph here called basic secondaries, and it has a bunch of parameters. So scale min, scale max, near, far, point spacing, and distance. And then if you look at the source of that, this basic secondary source graph, This is the graph. I'm not going to go into it, but basically takes those parameters that we just saw and applies a bunch of manipulations to the point. So the easiest way to look at child boulder transform, and sorry, it is under, no, it's not core, sorry. And child boulder 2 transform is that they're both using the same graph, but they're changing the parameter settings, but they're both executing this graph. And then there's also a very simple graph. So here, duplicate points, duplicate up, move up. These are very simple graphs. So if you look at move up, it is simply doing a transform points, and it is moving the asset up 500 units. It's doing no rotation and no scale. So there are some simple ones in the core folder that you can look at, such as duplicate and transform. And then there's this more complicated one, which is used in these child boulder transforms. So if I take a look at my setup, let's go to my grasslands. So if I go to my biomes, grassland, and my grassland setup, I am generating this rock, and I am applying a rotation and scale in 360 degrees. So my transform points is basically rotating it and scaling it uniformly since it's a rock. And if we run that as it sits, we go find those rocks. Oh, they're over here. So my rocks are being generated, and they're being culled back from the water's edge since I have the water filter on. And you can see that, the rocks, this one is on a little tiny piece of land. But the rocks are varying in size and they are varying in rotation. If I were to clean that up and change I'm just going to put this over to the side here, and I'm going to change that to let's start with boulder 1. So we're going to apply this instead of scaling and rotating it. I should have showed you the filters. So I still have a water distance filter on these assets, density filter and height filters. If I now generate the graph with this new child border transform, you'll see that the rock has been sort of obliterated into these tiny points. So anywhere there was a rock is now a bunch of rocks, and those bunch of rocks are scattered around the point that the original rock was. Clean that up, and I'm going to use the second transform and run that again. Then you'll see what this second transform does. So the second transform, you see you have much smaller scatterings of rocks, right? It's not nearly as dense as the other transform was. So that's using the transform to replace an asset with a bunch of assets. Or in my case, I did a rotation and scale transform, which would change each of these rocks and vary their scale and transformation so that they would look like this. So that's how that one works. I'm not going to do the assembly one. You can experiment with that on your own. The rest of the video, we're going to talk about the actual filter objects and how that works. All right, so now let's look at the filter elements to go through those. So what I've got here is my, this is my hardwood forest, and I'm looking at my hardwood asset. I just have it, this is our hardwoods. And I have two array elements, these trees that are spawning right here. And they have these seedlings, which are these little green dots below it. And then I have a second index where I am generating tree B. So this is tree A, this is tree B. They are basically just two slightly different variations of the trees. I may not be able to find it. But what you'll notice is that on my filter options, if I say height max of 6,000 for that, yes, just didn't happen to have any generated. All right, I have this plane, and I set that plane at 6,000, so I'd have a visual cue of where 6,000 is. So I make that bigger. That's basically 6,000. And so everything above this plane is above 6,000 and currently not generating any trees. So if I go here, I have 5 times as many tree A as I do tree B. In fact, let's disable tree B altogether. So we're only dealing with one data set. That way I make changes, it'll affect all the trees. And let's change our height max from 6,000, which is at or below this plane, to let's go with 9,000. And you'll see that trees are now generating all the way up to the peak of this plane. So 9,000, and this plane is at 6,000. So what if I said, okay, I only want them to spawn between 6,000 and 9,000. And then you'll see that all the trees of the hardwood forest disappeared, except those trees that are between 6 and 9,000. All right, so that's how the height range goes. So I'm gonna make my height minimum back to, let's call it 0. You can make it negative as well. And all my trees are gonna come back. And you see that I have all these hardwood trees. If I change my density filter, so this is the only tree I'm spawning. If I go from 0 to 1, I think I'm generating a lot of trees. I end up with a very dense forest, one tree for every point in this hardwood forest. So I'm going to basically just say, you know what, I'm only going to keep, oh, great, auto-saving 13,000 trees. I'm only going to keep 10% of the trees you generate, and that should thin out our forest to a much thinner forest. So this forest is spawning 10% of the points. It has no minimum. It's up to 9,000. So again, if I didn't want them here, I would make this a 6,000 height max, and that would stop these trees from spawning on top of this surface. Now note that the tree calculation is at its point of origin. So if a tree base is at the 6,000, it will still spawn, but there are no bases above 6,000. On the water plane, let's see if we'll do that with the rocks probably. So we're going to, I think I'm going to leave this the way it is. I'm just going to turn back on my other tree. And let me get my grassland asset here. And I only have one option, which is this stone that's being generated here. And my water distance, let's go with pushing the water distance back. So the minimum, I don't want them any closer than 1,000 units to the water. And I want them to stop at, oh, give it a second. So no closer than 1,000 units. And you'll see that all these rocks have disappeared. And in fact, they're gone. That might have been a bit aggressive. Water max of 10, that's a problem. Max distance from the water will be 5,000. All right, and we get some rocks back. So the rocks, let's see if I can make this 3,000. And you see that these rocks here in the middle disappeared. Not 100% sure why that rock is still there. That is triggering at a distance of 3,000. But then once I get 5,000 feet or 5,000 units away from water, the rocks stop. So if I want the rocks to go further away, 10,000, we'll get more rocks spawning up on this hill. And maybe I should increase my sample size. Let's go to 0.4 to 0.7. And I actually don't think this matters much, whether you're like 0.7 to 1 or 0.4 to 7. Yeah, so I'm getting more rocks further away. Not sure why the water distance now seems to be working properly. So water distance is now generating properly, and that nothing is generating all the way down to the water shore. Maybe I need to clean up the graph, so let's do that first. Hit the biome core, we're going to clean that up. And then what we're going to do is make this back to 250 and generate. Sometimes the auto regenerate doesn't. All right, so 250. I'm still a little close to the water's edge with some of these rocks. I'm gonna go 1,000. It's auto regenerating. I think I prefer to clean it up first. And the rocks are pulled back. Now they are pulling back based on where I set the graph for the water height. So if you remember, I'm going to leave this here at 1,000 units, is the minimum. And in our biome core, we are using this filter. And this filter is using this array. And that is using this water distance filter. And what I've set here is that my water level, if I can get this big enough, my water level is set to 1550. And if I click on my water plane, my ocean body water is at 1500. So I have slightly offset my water level from my water plane, which you can do. So if I want to be precise, the water level is at 1500, not 1550. And I think if we watch down in this corner, sometimes it's hard to get all this on the screen at the same time. So the water body is sitting at 1550. My constant water level is setting at 1550. I am generating points all the way out to 20,000. And then in our grassland, I knew this was going to be a problem. In our grassland folder, we are saying that we want it from 1,000 to 10,000. So I'm going to cut off at 10,000, even though I'm generating points all the way to 20,000. If that makes sense. And then by adjusting this min, these rocks should retreat away from the water plane. And you see them disappearing. So you may have to play around with the numbers a little bit to get what you're looking for. Here, this actually looks pretty good. So I'm going to minimize this. So I now have rocks that are spawning off the water surface. This is likely a different biome. Because my volume ends right here. So here's the end of my volume. And you can see that my rocks are spawning away from the water, not in the water, and not at the water's edge anymore. So that shows you the height, it shows you the water edge, and it shows you the density, because we adjusted density to limit our trees. And again, those are all coming from your PC Biome, Biome Core, this particular filter, and you could have as many of these as you want in this array. With the caveat that these either have to be $ positions, like density or Z, or they have to be an attribute that you set inside the actual graph. So this one's what's generating that attribute right here. So it says if the water level, do a distance and add the attribute water distance. So that matches up this, these right here. So if I were to add a new filter, one, I'd have to create a graph. I'd have to create a graph, or if I wanted to just do something silly, like $ position X, and then use the, this is gonna be a real silly thing, height min, height max. So I'm reusing these variables. Better remember to delete this. Height. Oh, it's because I don't have it constrained. So this is going to go in the x-axis this way, left to right, and it's going to only sample. This is going to be a little tricky. All right, what we're going to do is put an object down. I'm just going to put a tree. I'm going to hand place a tree right here. And hand place a tree here. And so those trees in the x-axis, so if you look over to this corner here, that tree is at minus 33690 in the x. This tree is at minus 41870. So if I wanted to change my min and max, my min is now minus 41870 and my max is minus 33690. And it should generate stones down through the middle. All right, so I wasn't getting a result because I was already filtering out Z positions that were not between these two low values, which meant all these were being filtered out on the first pass. So what I'm going to do instead is I've deleted my fourth filter, and instead what I'm going to do is filter this on position X so that there is no Z filter, and there you see the rocks have manifested in between these 2 points in the x-axis, so between this tree and this tree. So I'm now using the position X, and I'm using the variables height min, height max. But again, of course, if I did the Z here, they're going to get filtered out this way first, and since my landscape is higher than that, they're all getting filtered away. That's why when I added the extra one, it didn't make any difference. So now I'm going to go back And I'm gonna take these back to anywhere from minus 100,000 to plus 100,000. Now we're gonna do one more cleanup and then we're gonna launch the game. Good, we're clean. We're gonna generate. We get our rocks, our hardwoods and softwood trees throughout the world. And then we're gonna go jump in game and play, because each of these assets are in fact based on base tree, which are based on our resource node from prior videos, which are based on our Lyra World collectibles, which allow us to pick up X number of charges, in this case 3, and give us some raw material into our inventory. So we're gonna go ahead and chop down some trees and pickaxe some rocks. And we're gonna go F11 for full screen. We're gonna get auto logged into this map. We're gonna pull up our inventory. Note that we have just meat as our resources. We're gonna head to this rock. Because it's an interactable actor, we're gonna go ahead and interact with it 2, 3 times, and we got stone. So you see we have 3 stone. We're gonna go over to one of the trees. And again, chop it down, animations to follow. And we have 3 resources from that tree. So the biome is generating the actors, and the actors are set to give us resources based on the configuration. And so that is how the filters work, the transforms work. Oh, and we're running out of food. The filters work, the transform work, and we talked about the assembly. So hopefully that's helpful for some folks. We're going to end this little look at the PCG biome here, and we're going to sort of continue to advance our systems in a couple of other areas. Thanks for watching.